let us see now the addition of vectors. So when we say addition of vector, it means we are supposed to find the resultant of two vectors. So let us say we have the vectors A and we have another vector as B. Now we want to add these two vectors. When we say we have to add these two vectors, so it means it is not to be algebraically, it is not to be added, because algebraically we can add or subtract only scalars. But when it is a case of addition of two vectors, it means it has to consider the vector addition. So when the representation as far as the addition is concerned, we will have this vector A plus this vector B. Now when we consider vector A plus B, so we can have various orientation. Whether you write vector A plus B or you write vector B plus A, it hardly makes any difference. So we can write vector A plus vector B or vector B plus A. And suppose we have vector D plus E plus F. That can be considered, that can be expanded as vector D plus vector E plus F. Either we add this E plus F first, then this D, or D plus E first and then that F. It hardly makes any difference. So these are some of the properties of the vector addition. Now how to add these vectors? Now as far as the vector additions are concerned, there are certain prerequisites. Let us see as it is represented here. Here this is your vector A and this is vector B. Head of the first vector, now we are talking this dramatically how we can add it. Head of the first vector, if it is joined with the tail of the second vector, this is your vector B. If you call it as second vector, then this is vector A. So head of the first vector, this is vector A, and this is the tail of the second vector. If these 2 points are joined together, then join the tail of the first vector with the head of second vector. That line gives you the resultant of these two vectors. Resultant of this vector A and B. I will elaborate it further. Let us say you have this vector A. Suppose like this. The first vector. Second vector is, suppose we have this B. So head of the first vector, it is joined with the tail of the second vector. Tail of the second vector. Then join the tail of the first vector with the head of the second vector. So we have this line. Suppose we get a third vector C. After adding this vector A and B, we get a third vector C. So this C is represented joining the tail of the first with the head of the second. Then we say that vector C, it is equal to your vector A plus vector B. This is the condition that head of the first vector, it should be joined with the tail of the second vector. Then join the tail of the first vector with the head of the second vector. That line gives the resultant of the vector. So if it is suppose C, so we write vector C is equal to vector A plus vector B. Now here, suppose we have vector A like this and vector B like this. Okay. Now here tail of the first, it is joined with the tail of the second. So we will not say that this is the vector C, joining the head of the first with the head of the second. So this is wrong representation. Always that condition has to be satisfied. Now that condition, that head of the first, it should be joined with the tail. That is required, that is necessary, so that we can take proper care of the sign convention. And the sign convention is angles are always measured in the anti-clockwise direction and measure in the anti-clockwise direction. So here if you consider this as far as the measurement of this is concerned, suppose this is your x-axis and this is y-axis. Angles are always measured, let us say theta, in the anti-clockwise direction. If you say angle between the vectors A and B, theta. So angle between the vectors A, let us say this is your A and this is B. Okay. So angle between the vectors A and B, when we say this statement A and B, means from A towards B. When we say B and A, means from B towards A. So angle between A and B, if it is theta, it should be from A to B in the anti-clockwise direction. That is the convention that we always follow if angles are to be measured. So it is always considered in the anti-clockwise direction with respect to the first vector and the second vector. So between A and B means from A towards B in the anti-clockwise direction. So here, if this angle is theta, then we will take this angle as theta. So this is A and B. So always in the anti-clockwise direction with respect to the first vector. When we say first vector, so here if it is A and B, then it will be A will be treated as the first vector, B as the second vector. So like this. So here, if you consider suppose a vector along x-axis, let us say this, and this is your vector B. So from A towards B in the anti-clockwise direction with respect to what? Positive x-axis. So this is your positive x-axis. This side it is negative, again this side positive y-axis, this side it is negative with respect to positive x-axis. Is this clear? So always we can consider this. We can also consider this as your x-axis. X and y-axis are what? X and y-axis are nothing but the two lines which are mutually perpendicular to each other. If we consider this line as the x-axis, then a line perpendicular to this will be considered as the y-axis. If you consider this as the x-axis and a line perpendicular to this will be considered as the y-axis. So if I have taken here as this line, so it can be considered as the x-axis, then another line perpendicular to this, it will be considered as y. This is your another vector, this B. So angles are always measured in the anti-clockwise direction with respect to positive x-axis, and it starts from the first towards the second vector. So that way we consider this. Now when I say the head of the first vector, it should be joined with the tail of the second vector, then join the head of the two vectors, then the tail of the first with the head of second. That line always gives the resultant of the vector. So this is the convention, so that we can take care of the magnitude as well as take care of the directions properly without any confusion or without making any mistake. So here these are the different representation. Vector A. Similarly, you have this vector B. So vector B, this side, if it is taken positive, so this side it will be taken what? Negative, any minus of B. Negative means minus of B, that means in the opposite direction. So we have this minus B. Now this is your vector A and this is vector B. So this becomes what? A minus B. In fact, it is A plus B, but A plus opposite of B. So A plus opposite of B means what? Minus of B, and that's why here it is A minus B, because this is our A. No, sorry, B. So actually B is in this direction, so minus of B it will be in this. Now we are adding what? This line is parallel. This line is parallel to this. So we are making or adding A plus this vector, and this vector is not B, this vector is opposite to B, so it is minus of B. So this is also the resultant of the two vector. One vector is in the opposite direction of its actual direction. So these are the different representations. So you can see this A minus B is nothing but A plus minus of B, means if you have to subtract the two vectors, so make the second vector in the opposite direction, and that becomes the addition of the vector. So addition or subtraction, they are almost same thing. Only thing is the vector has to be taken in the opposite direction of its real direction. Now, before we consider this addition of the vector further, because we will need resolution of the vector, just to simplify, just to have more elaboration as far as the addition of vector is concerned, we need the resolution of vectors. So let us consider this. Resolution. Resolution of vector means finding the component. When we consider addition of vector means finding the resultant of the vector. So similarly, the resolution of the vector means finding the components of the vectors. So suppose we have this vector A, okay, and A is making some angle theta with the x-axis. So the direction of A is theta with respect to positive x-axis. Now this vector A is having some magnitude, it has its direction, and that direction is theta with respect to positive x-axis. So it will have its value along x-axis, and it will have its magnitude along x-axis as well as magnitude along y-axis. Direction will remain same, that is theta. So what are those values? So drop a perpendicular line from here on the x-axis as well as on the y-axis. This part this part will be considered as the magnitude of this vector A along x-axis, and this part will be considered as the magnitude of this vector A along z. So this AX, if we represent this part as AX and this part as AY, then AX and AY, it will be termed as the components of the vector. We say AX and AY are the components of the vector A, where A is the resultant of these AX as well as this AY. Component of a vector, it is a scalar quantity, because when we consider this AX, so we are just considering the magnitude part of this, the value of this A, magnitude of this A along this, magnitude of A along this. So that becomes the component of a vector. It is a scalar quantity because we are just interested in the magnitude part of this. Again, if you say that this component is along x-axis, then again we are changing that scalar to a vector quantity, because we are defining its direction, that this is along x-axis. So in that word it becomes a vector quantity. Otherwise, when we are resoluting this vector A, when we are finding the component of this A, we are just finding the magnitude part of that along x-axis as well as y-axis, or in general along any two mutually perpendicular lines. Components of any vector quantity, it can be calculated along two mutually perpendicular lines in general. X and y axis are nothing but two mutually perpendicular lines. It can be represented like this and like this. It can be represented like this and this. This is your x axis and this will be y, provided this angle is 90 degrees. So it can be along any two mutually perpendicular lines. Now here, so how to calculate the value of this AX as well as AY? So when we have dropped this perpendicular, so obviously this is a right angle triangle. Now if this angle is suppose theta, then cos theta in this triangle, cos theta in this right angle triangle, that will be equal to how much? You can consider cos theta is equal to base upon hypotenuse. So base upon hypotenuse, so this is how much? AX, we have assumed that AX, hypotenuse is A. When we say A, we are talking only on the magnitude part of this vector A. So base upon hypotenuse, so AX upon this A. So from here, you can calculate this AX is equal to A cos theta. Similarly, if you consider sine theta. So if we consider sine theta here, then sine theta is what? Perpendicular upon hypotenuse. Then this side divided by this side. So this side is how much? AY. So that becomes AY upon this A. So again from here, AY, it is equal to how much? A sine theta. So x component is your A cos theta and y component is A sine theta. So this is A. Just using the concept of the right angle triangle, cos theta is based upon hypotenuse. From there you will get A cos theta. Sin theta is perpendicular upon hypotenuse. You will get this AY is equal to A sin theta. Just using this calculation. So using that, so we can calculate the various components of the vector along x-axis and y-axis, AY as well as this AX. So these are termed as the components of the vector, and this process of finding the component of the vector, that is termed as the resolution of the vector. So here you can see AX equal to A cos theta, AY is equal to A sin theta. These are supposed to be in general scalar quantity because this represents only the magnitude. Here also when we have written this A, we are not putting any vector notation. We are only taking the magnitude part of this vector A. I hope this is clear. Now, if you want to find the resultant again, if AX and AY are known, then resultant will be what? This is a right angle triangle, so you can use the Pythagoras theorem. AX square plus AY square root, that gives you A. This is square plus this is square root, we get this A. So AX square plus AY square, that is A. So again it gives you the magnitude of that vector A. Now, what is the direction? If you want to calculate this angle theta, how to calculate theta? So tan theta is equal to how much? Tan theta is this component upon this component. So using that concept, we can calculate this angle theta. So tan theta, that you can see here, is equal to y component divided by x component. So tan theta is equal to AY upon AX, magnitude, yani direction of this A. If you want to calculate tan theta, and once you calculate tan theta, you will get the direction theta is equal to tan inverse ay upon this ax. Similarly, the magnitude is square root of ax square plus ay square root, and that way we can calculate. So from resolution to the resultant of the vector, and from resultant to the resolution, so we can analyze this way. So here you can see on this. Now, what is the advantage of resoluting a vector? Because when you consider the vector addition, when we want to calculate the resultant, let us say vector C is equal to vector A plus vector B. We can't have, other than the symbolic addition or symbolic representation, we can't have the vector addition. So what to do? Find the resolution, find components of the vectors along x-axis, y-axis. If it is 3-dimensional, then along z-axis also, x-axis, y-axis and z-axis. If it is 2-dimensional, find components along x and y. Now if you find this, if you suppose this is a symbolic representation of this. Now Cx is suppose the x component, resultant of the x component of the vector, and Cy is the resultant of y component of the vector, let us say. So here this is equal to how much? Ax, and this is equal to how much? Ay. Just now we have calculated. So Cx square plus Cy square root, that gives us what? The magnitude of this vector C. Magnitude of this vector C, that will be equal to your Cx square plus Cy square root. And Cx equal to how much? Ax, and Cy is equal to how much? Ay. So simplify, so find the component of the vector, and using the simple algebraic calculation of finding the resultant of the quantities, we have square root of Cx square plus Cy square. C, this vector C, if resultant of this vector C, suppose this A and B, if it makes angle theta, with the x-axis, I am not talking of the vector A and B. If the resultant of the vector A and B, if it makes angle theta with the x-axis, then what will be the direction of that C? If it is suppose theta, then tan theta, it will be equal to how much? Y component divided by x component, means y component upon x component, and here y component is how much? Ay, and x component is how much? Ax. So that way we can calculate this tan theta. Okay. So this here we have taken only two vectors, vector A and vector B. If there are suppose any number of vector A, vector B, vector C, vector D, and so on. So the resultant R, it will be equal to how much? If it is suppose the resultant R in general, then it will be equal to how much? Vector A plus vector B plus vector C plus vector D, and so on. So this is the vector addition. Direction of this R. So direction of this R, if it is theta, direction of the resultant vector, if it is suppose theta, then tan theta, it will be equal to how much? Summation of y component of all the vector divided by summation of x component of all the vector. Now here all these vectors will have the x components, as here we have seen. In case of only two vectors, we have the component of A, we have component of B. So Ax as well as Ay. Now if you are having suppose many more vectors whose resultant is to be calculated, which are supposed to be added, then we will have x component of this, x component of this, similarly this and so on, and y component this. When we calculated x component of all the vectors, so they are what? Scalar. So they can be added algebraically. Y component of all the vectors, they are also scalars. So it means again they can be added algebraically. So we have this ax of this plus bx of this, cx, dx, and so on. So we can add them. So that becomes what? Summation of this x. Similarly, y component of all these vectors. So that will be equal to your addition or summation of that. Once you know the summation of all the vectors along y-axis, summation of all the vectors along x-axis, or the magnitude of all those vectors, then tan theta, the resultant of these vectors that makes angle theta with the x-axis, that will be nothing but sum of all the components along y-axis divided by sum of all components along x. And the resultant value, the magnitude of this r, if you want to calculate magnitude of this r, that will be how much? All the x components are known to us, all the y components are known to us. Summation of this x square plus summation of y square root. So this gives you the resultant. So now let me summarize. Whether it is a case of addition of two vectors or any number of vectors, calculate the x component of all the vectors, calculate y components of all the vectors, summation of x, summation of y. Resultant, yani magnitude of the resultant of the vector, it will be summation of x square plus summation of y square root. Direction of the resultant, if it makes angle suppose theta with the x-axis, then tan theta of that, it will be summation of y divided by summation of x. That is the simplest way to find the resultant of any number of vectors. So it means the resolution of vectors are needed so that we can convert the vector as far as the magnitude part is concerned in the scalar form. And once we have that scalar quantity as the magnitude, we can simply use the concept of this algebraic addition and we can calculate whatever is required. So now we can again continue with the addition of the vector. So here in this diagram you can see we have the vector A, there is another vector B, and angle between the vectors A and B, it is theta. Now, so this is the head of the first vector, this is the tail of the second vector. Here you can see this is vector A and this is vector B. This side is the head of the vector B, this side it is the head of the vector A. Now we have joined the tail of the first vector with the head of second vector. So this gives us the resultant of the vector A and B, and that is suppose C. So we have the vector C as the resultant of the addition of the two vectors A and B. So C is equal to A plus B. Now when we consider this equation, vector C is equal to vector A plus vector B. So this is the vector equation. When we say vector equation, it means the magnitude of the resultant vector is C. So magnitude of the resultant vector C as well as the direction of the vector C, both are included as far as this equation is concerned. So the only thing is we have to always consider the condition as far as geometrical representation is concerned. You have to consider this condition that head of the first vector, it should be joined with the tail of second vector, then join the tail of first with the head of second, you get the resultant of the vector. That is the prerequisite or the basic relation. And why we do this, why we require this, that we have discussed that angles are always measured in the anti-clockwise direction with respect to positive x-axis. So here angle between A and B, it is theta. So when we say angle between A and B is theta, so we have not taken this angle as theta. Because here, if you take this angle as theta, let us say from A to B, angle between A and B. So when we say A and B, so it should always be measured from A towards B. So if I take this angle as theta between A and B, that means we are proceeding in which direction? In the clockwise direction. But the standard convention say it should be taken in the anti-clockwise direction with respect to positive x-axis. So here you can say that this is the vector A and this is vector B. Why we are taking this angle theta? Because just to meet the required condition, this point of intersection will always be considered as the origin. So if you take this as origin, so with respect to this, we can consider this extended line. So that with respect to this origin, this becomes your positive x-axis. Now this line and this line, it is parallel. So we say angle between A and B theta, or angle between this line and this line theta, it becomes same, because this line and this line, they are parallel or coinciding lines. Now, positive x-axis in the anti-clockwise direction. So we have now created this positive x-axis, taking this as the origin from A towards B. So now I am taking from A, this line is parallel to this. That's why either you say from A this or from A this in the anti-clockwise direction. So in the anti-clockwise direction from A to B, so this becomes your theta. That's why we have considered this angle as theta, not this angle as theta, because here it is measured in the clockwise direction when we read it at A to B. When A to B, we proceed in this direction, so this becomes your anti-clockwise direction. This is the point of origin, so this becomes positive x-axis. It means all the conditions are satisfied. So we have to meet the condition and then only we can measure this angle theta. I hope this is clear. Now, so now vector A is here, vector B is here. This angle is theta between A and B. Now we have this resultant vector, this C. So let us calculate. So we have this vector equation, vector C is equal to vector A plus B. Now one by one we will calculate the magnitude of this vector C as well as the direction of the resultant vector. The direction that it will make with the x-axis. That is again standard convention. Generally when we calculate the direction, so we try to define in terms of x-axis. We can define in terms of y-axis also, z-axis also, but we have to specifically mention what is the direction with respect to what axis. So here, just to calculate the magnitude of this vector, see now we will resolute the vector. Just now we have seen how to resolute the vector. So drop a perpendicular from here. Okay, now this is B. It makes angle theta with this axis. So again taking this cos theta here, cos theta is equal to how much? Base upon hypotenuse. So this part, if it is suppose x, then that x or bx, this part is suppose it is bx. So this bx, that we can calculate using the cosine relation, cos theta base upon hypotenuse. So this gives you bx is equal to b cos theta. So bx, it is equal to b cos theta. Similarly, this is suppose by. So by means y component of this along this y axis, because this line is parallel to this. So that will be how much? B sin theta. So already we have discussed all this, and again if you have any confusion, you can just consider this as right angle triangle. Cos theta you can consider this side upon this side. Sin theta you can consider this side upon this side. So from there we can calculate bx as well as by. So by it will be equal to your b sin theta. Okay, so this is b cos theta, this is b sin theta. So this part now we have known, we are having this part as bx and this part as by. Now here you can see I have not put vector notations here because we are just interested in the magnitude part of this, because we want to calculate the magnitude of this resultant vector C. So bx is a component which we have already said it is a scalar quantity. B here I am only taking this magnitude part of this b. So b cos theta, here also it is b sin theta. So this part, this total length becomes how much? A plus bx. Okay, and this length becomes how much? By. Now again this is a right angle triangle. This bigger triangle, it is also a right angle triangle. So in this right angle triangle, using the Pythagoras theorem, this square is equal to how much? This square plus this square, and from there we can calculate the magnitude of that. So can you say that c square, again I am not taking this vector notation as far as c is concerned. Now I am only interested in the magnitude part of these vectors. So c square, it will be equal to your a plus bx whole square plus this by whole square. A plus bx, this total length is a plus bx, again the magnitude of a, and this bx, so a plus bx. So a plus bx plus this by square. So from this you can calculate c square is equal to a plus bx, bx is how much? B cos theta. Okay, plus this b sin theta whole square. So this will be equal to a square plus b square cos square theta plus twice of ab cos theta. So a square plus b square cos square theta plus 2ab cos theta plus b sin theta whole square means b square sin square theta. So this b square cos square theta plus b square sin square theta, that becomes your b square, because taking b square common, cos square theta plus sin square theta, that becomes 1. So from here you can say c square is equal to a square plus b square plus twice of ab cos theta. A square, this and this makes it b square plus 2ab cos theta. Now once c square is gone, so we can obviously calculate c taking the square root of this. So from here you can say the magnitude of the resultant vector, it is a square plus b square plus 2ab cos theta. So this is the resultant of magnitude of the resultant vector. So this way we can calculate it. So what is the concept? Calculate the x component of this vector, y component of this, calculate this total length a plus bx. This becomes your by. Just use the Pythagoras theorem. You will get the magnitude of the resultant vector, that is a plus bx whole square plus by square root, and from there we are finally getting this relation square root of a square plus b square plus 2ab cos theta. Now what is the direction that this resultant vector c makes? So let us say this vector or this resultant vector makes angle alpha with the x-axis along this line or with respect to that line. So tan alpha, when we need to calculate direction, generally we use this tan. So tan alpha, this will be equal to how much? This side upon this side. So tan alpha is equal to your by upon a plus bx. So tan alpha is equal to by upon a plus bx. So by is equal to how much? B sin theta. And this will be equal to a plus b cos theta. So this way we can calculate that. So this is the direction of the resultant vector. So from here you can say alpha is equal to tan inverse of this. This is the magnitude and this is the direction. Now let us summarize all this. I hope this is clear. Let us summarize. What is this side? We have taken the component of this as well as component of this. Y component of this A means magnitude of this A along this direction is how much? 0. Because it is only along the x-axis. Y component of this along this is by. X component of this along this is A, because it is already along this A. I am talking only of the magnitude part. Y x component of this, it is bx. So in this right angle triangle, when we are calculating this C, magnitude of C, this line represents nothing but y component of this A plus y component of B. Y component of A, it is 0 here, and that's why it is 0 plus by. Along this x component, it is a plus bx. So can you say, when we write this equation a plus bx whole square, it is nothing but the summation of x square, that is sum of all x components, this vector as well as this vector. So summation of x component of the vectors. This side is what? Sum of y component of the vector. So it is by only just because the y component of this vector A, it is 0. So it is 0 plus by whole square. So just to generalize this, we can write sum of x component of all the vectors square plus summation of y component of all the vectors. This you can write here. Okay. Summation of x whole square plus sum of y square. So this is the general representation. Now we are trying to generalize the situation. We don't want to keep ourselves limited only to the addition of two vectors. So here we observe, this is the x component of both the vectors, sum of x component of both the vector. This is sum of y component of both the vector. Here only by appears just because y component of this, it is 0. So to generalize, summation of x square plus summation of y square square. Now just to calculate C, we will take the square root of this. Here also we have this a square plus b square plus twice of ab cos theta. Now again alpha. This is again summation of y divided by summation of x. Summation of y component of all the vectors divided by sum of x component of all the vectors. So this is the general method. So here to generalize we can consider tan alpha is equal to summation of y component of all the vector divided by sum of x component of all the vector. So this way we can calculate the angle that the resultant makes with the x-axis as well as the magnitude of the resultant vector. Now see, here we have just added two vectors, vector a and b. It is square root of a square plus b square plus 2ab cos theta. You can consider this as a relation, standard relation as far as the addition of two vectors is concerned, provided angle between a and b is theta, and this can be considered as the angle of the resultant that it makes with the x-axis. So these relation you can keep in your mind, and wherever necessary you can use it. But what I will suggest is, what is this? This is nothing but the resultant of x component as well as the y component. And x component and y component, they are always mutually perpendicular. When two quantities are mutually perpendicular to each other, using Pythagoras, we always calculate the resultant at x square plus y square square root. So simply x square plus y square, this is square root. That is the only thing that you have to keep in mind. That is just the understanding. There is nothing to memorize or remember on this thing. The alpha, the resultant that it makes with the x-axis alpha. So again, tan alpha is always perpendicular upon base. So y component and divided by x component. So summation of all y component divided by summation of x component. So this way we can always calculate the resultant of two vectors in particular and resultant of any vectors in general. Now when we consider, when you start simplifying problems in physics, so vector, particularly this vector, no one is going to ask you except this particular topic, add this vector, subtract this vector, find the components of the vector, find the addition of the vector. You will have the application of all these things. We have to find the resultant of all vector quantities. When we say all, depending on the requirement of my problem which is given for me to simplify. All vectors, when we say all vectors, it can be forces, it can be impulse, it can be magnetic induction, it can be anything. So wherever you need to simplify, just consider the x components, y components, get the resultant. X square plus y square square root is always the resultant because x and y are mutually perpendicular to each other. Tan alpha is always perpendicular upon base, so y component divided by the x component. This is so simple, and we will always use this concept to solve any type of question where more than two vectors are involved. Particularly two vectors are there, then you can directly use this relation, substitute the values and calculate it. So let us see. So now we can see the addition of some more vectors. So here in this diagram, if you see, we have this vector A, we have vector B, vector C, vector D, vector E, inclined at different angles. You can consider that displacement, and displacement is a vector quantity. So a person is moving along this direction, then along this, along this, along this, along this, and so on. So we have to find the displacement or the net displacement of the particle or the object. So here, so when we consider this vector A in general, vector B, it is at an angle of alpha. Any angle between this A and B, it is alpha. Angle between this vector and along the x-axis, again it is beta. These lines are parallel to x-axis, so you can consider as an x-axis or extension of the x-axis. So it is beta, it is gamma, it is delta, and so on. So now how to calculate? So first you check whether the condition for the addition of vectors are satisfied or not. So head of the first vector is joined with the tail of second. Again head here, it is tail of this vector, it is joined with this. Tail of this vector is joined here. Tail of this vector is joined here. So that condition is satisfied. So join the tail of the first with the head of the last vector, yani the final vector. Okay, that gives us the resultant of all these vectors. So when we say this R, vector R is the resultant of all these vectors. So we can write this vector R is equal to vector A plus vector B plus vector C plus vector D plus vector E. So this way we can calculate it. So again, this is a vector equation. Again, in this, magnitude of this R as well as the direction of R, both are included. So now we have to separate what is the magnitude of the vector R, what is the direction of this vector R, that is the resultant vector that makes it with the x-axis. So let us say this vector R makes angle theta with the x-axis. So we have to calculate this theta as well as we have to calculate magnitude of the vector this R. So how to proceed? Now here in this there are so many directions, all the vectors are at different angles. So we can't use that simple equation of addition of vector a square plus b square plus 2ab cos theta square root of that and so on. So that is limited only for two vectors. At the most what you can do, first find the resultant of these two vectors, then that resultant again with this. So that becomes a very complicated and confusing situation, because again you have to calculate the direction of the resultant of these two. That direction should be considered with the vector c. So step by step it becomes very lengthy, very confusing, and that cannot be suggested. So what we will do, just now we have seen calculating resultant means what? Summation of x square plus summation of y square square root. That is the resultant. Tan alpha or tan theta, the resultant, that angle it makes with the x-axis. That is what sum of y component of all vector divided by sum of x component of all vector. So we will always consider this whatever be the number of vectors or any other physical quantity which is a vector quantity. So it means if you can consider this to calculate the magnitude, x component of R. So x component of R means summation of x component of all the vectors. So that will be the resultant component of this R along x-axis. So first we will calculate that. Then the resultant component of R along y-axis. So that will be Ry. So can you say this Rx is equal to Ax plus Bx plus Cx plus Dx plus Ex. Means x component, sum of x component of all the vectors. Once you calculate sum of x component of all the vectors, we will get the x component of the resultant. So now let us calculate the x component of all the vectors. X component of vector A, it is same as A because it is already along the x-axis. Because if something is along x-axis, its y component, it will be how much? 0. Because theta here it is parallel to x-axis. So parallel to x-axis, so angle will be how much? 0. So cos 0 it is 1. So that will remain same as this A. So here it will be A plus Bx. B is making alpha with the x-axis. So component will be how much? B cos alpha. So plus B cos alpha. Plus Cx. This is C. This angle is beta. You can see this here. It is already in the anti-clockwise direction. Now you may be having that this is an obtuse angle. We are not bothered about whether it is an obtuse or it is an acute. We will just consider the x component of this. If it is an acute angle, cos alpha, it will be with the positive sign. If it is an obtuse angle, cos alpha itself will be with the negative sign. So that will take care of those signs, plus sign or the minus sign. Because if you take this line this side, okay, so it is obvious from the diagram that its x component will be this side and y component will be this side. And if you take like this one, so obviously x component will be along this line and y component. So it seems that x component here should be negative. Now here it is acute angle alpha. Here it is suppose obtuse angle alpha. That acute angle and that obtuse angle, that will take care. So because here cos alpha, that will be positive. Here cos alpha, it will be negative. So whether it is component this side or this side, that cos alpha or the component itself will define. If it is acute, it will be with the positive sign. If it is obtuse, it will be with the negative sign, and that negative sign will only imply that it is not along the positive x-axis, it is along the negative of x-axis. So that they will take care of themselves, so we need not worry about that. So we are considering this Rx. So Rx we have mentioned A plus B cos alpha plus how much? C cos beta. So that is C cos beta plus D makes angle how much? Gamma. So D cos gamma plus E makes angle delta. So E cos delta. So this is the x component of all the vector, and Rx gives the resultant of all this. Now all these are scalar quantity. So again, don't confuse. And all are along the x-axis. So simply we have to add them algebraically. Again, there is no need of any vector addition and all that, because all these are scalar quantity along the x-axis, along the same directions, whether it is positive or negative, that will be taken care of by the values of this alpha, beta, gamma, delta, and so on. So simply we have to add it. Similarly, calculate Ry. Then y component of all. So y component of this vector is how much? 0. Because if something is along x-axis, so its y component 0, because sine 0 it is 0. It is making angle 0 with the x-axis. So component will be sine 0, and sine 0 that becomes 0. So it will be 0 plus y component of this b. So y component of this b is how much? B sine alpha. So it is b sine alpha plus c cos beta is the x component, c sine beta will be the y component. So c sine beta. How it is cos beta sine beta? I hope you are clear with that. That we have already taken. Consider. At every stage, if you want to have this stepwise, consider the right angle triangle. Take that cos alpha or cos beta, and similarly sine alpha or sine beta in that right angle triangle. Use the concept of triangle law, simplify, and you will get all that. So C sine beta. Next it is D. Here it is gamma. So D sine gamma. So plus D sine gamma plus E. So E makes angle delta. So E sine delta. So this is your y component, and this is x component. X and so all values we have calculated along this x as well as y. Okay. This is suppose y axis. So this is Rx and this is Ry. Rx means sum of all this along this line. Sum of all this along this line. So Rx and Ry it is known. So R will be what? Resultant of these two, and they are always mutually perpendicular. So when they are perpendicular, so we will get this as Rx whole square plus this Ry whole square. So just simplify this, substitute the values, and you get that value. If this makes angle theta, suppose this is theta, then theta component of R is how much? Rx. Component of y component of R is how much? Ry. If this is your R, so its y component is suppose Ry and x component is Rx, as we have this Ry and Rx. So tan theta, that will be how much? Y component of this divided by x component of that. So tan theta, you will get Ry divided by Rx. So again calculate this value, substitute here, you will get this theta. So this is the simple rule. Whenever we have to calculate addition of many vectors, now that vector can be your forces, it can be impulse, it can be momentum, it can be magnetic induction, or any other physical quantities which are vectors. So we can calculate the resultant of the vectors using them, calculate the direction of the vector using this. It means the only thing that you should keep in mind, whether it is addition of two vector or any number of vector, calculate x component of all the vectors, calculate y component of the vectors. X square plus y square root gives you the resultant of all those vectors. Y upon x, that gives you the tan theta, means the angle that the resultant makes with the x-axis. So this way we can calculate addition of vectors or resultant of vectors. So we will continue next with the position vector, and after that we will start simplifying problems based on all these concepts. Thank you.